Alright, so our first strategy in solving these trig equations would be to locate the correct strategy, the correct one in this list of six. So the first ones we can eliminate right away is it seems that there are no double angles. A double angle would look like this if you saw 2 theta somewhere in that equation. And similarly, there are no half angles. Half angle would look like theta over 2. So neither of those will apply. There's no Pythagorean identity. There's nothing like sine squared or tan squared in this. There's no trinomial. A trinomial would look like, let's say, some function squared plus another function plus a number, for example. That would be something like a trinomial. So we're down to strategy 1, strategy 4, and we'll go with strategy 1 because it looks like there's a lot of tangents here. So probably what will end up happening is that we can multiply or we can combine things that have tangents in them. So let's begin by adding the 3 tangent to both sides, because normally when we're with a lot of these equations, when we have to factor things, we want it to be in standard form. Just like when we were solving quadratic equations, we would always try to make the equation equal to 0. So we have negative root 3 times tan cotan, and then over here the negative 2 plus the positive 3 will be just plus tangent, plus 1 tangent. Okay, now we can see that there is in fact a greatest common factor. Both of those terms have a tangent in common. So let's pull out a tangent from both of those. And what is left behind? Well, if we divide this thing right here, this whole term by tangent, we will have negative radical 3 cotangent. And if we divide this one by tangent, we'll just have 1. So now we can solve this. It's equal to 0, and there's 2 ways that we can make this equal to 0. This part of it could be equal to 0, so tangent of theta is equal to 0, or this part of it could be equal to 0. Negative radical 3 cotangent plus 1 could equal 0. So now let's go back up to the top. It says identify which type of equation. So it was a greatest common factor equation. Solve it. We're about to do that. And then our last step is going to be using the unit circle, or using our table that we've memorized, the 30, 45, 60 table. So let's use the unit circle for this one. Tangent is equal to 0. If you look at the unit circle, first thing to remember is that tangent is the same as sine over cosine. So whenever sine is equal to 0, that means tangent will be 0, because if sine is 0, you'll have 0 over, we don't really care what cosine is in that case. So sine is the y coordinate. If you look at the unit circle, y is equal to 0 right here at 0 degrees, and y is also equal to 0 right there at 180. So our 2 solutions here will be 0 degrees and 180 degrees. Those are the 2 places where tangent is equal to 0. Okay, all of these problems will end up getting multiple answers. So those are the first 2 answers. Let's look at this other one. So we'll start, we want to solve for cotan here. We'll subtract 1 from both sides. So we'll get negative radical 3 cotan is equal to negative 1. Then we will divide by negative radical 3. So we'll get cotan theta equals negative over negative is positive. And then just to simplify this, let's make both, actually, you know what, let's keep it as is, and I'll tell you why. We'll keep it as 1 radical 3. We're going to rationalize it. The reason we're going to keep it as 1 radical 3 is we're not as familiar with what cotan is. We do know a lot more about tangent, though. So let's, instead of solving for cotan, let's just flip this around and solve it for tan, and whatever answers we get for tan will also apply to this. So if we flip that, remember cotan and tan are reciprocals. If we flip that, we get tangent is equal to radical 3. And if you remember this table, the sine, cosine, tangent table, okay, it's from these 3 angles. We have 30 degrees, we have 45 degrees, and then the last one is 60. We won't fill in the whole table, but hopefully you might remember which one is radical 3. Okay, it turns out that this one right here, the tangent of 60, is radical 3. So this goes back up to what we said above. It says identify the other solutions using the unit circle. So we know that one of these solutions will be 60. Okay, where is the other one? Here's the unit circle, and hopefully you recall what this means. All students take calculus. There are actually 2 places. This is a positive root 3. There are 2 places where tangent is positive, right here and right here. We just found one of them. We found out this one, which is 60. But we want to find this other one also, which is also 60. So the question is, what is this large purple angle right here? And it would be 180 plus 60, which is 240 degrees. So 60 and 240, if you plug them in for cotan, you would get this, or if you plug them in for tan, you would get this. So our final answer has actually 4 solutions. We have 0 and 180, and then also 60 and 240, and those are our 4 answers for this equation right here.